Hello mates. In the previous video we're talking about solar days. In this video we are going to talk about mean time. In the previous video we talked about sidereal time, and in the previous videos we talked about sidereal time. Then we introduced an apparent solar day. Now we're just going to talk about mean time. The problem with the solar day starts at 12 noon. It starts at 12 noon. So we needed something to calculate with. So people developed the mean time. So for scientific purposes, they introduced a third time known as mean solar time. It is defined as it is defined by a fictitious sun. So they created a fictitious sun that is just fiction. That is it's just an imaginary sun. So they called it the mean sun, which just the mean sun. What is special about this mean sun is it travels along the celestial equator. Let us do this. If this one is the south celestial pole and this one the north celestial pole, this one will be our celestial axis, and then perpendicular to that will be our celestial equator, like this. The problem with the normal sun that we have, that solar sun that we have, is it travels on a path that is at an angle to this celestial equator called the ecliptic. But now, so now that was difficult because it introduced some errors in the calculations. Just like you remember when we're dealing with them. When we're dealing with the sidereal time, we said some of the effects of the sun being at an angle to this is that stars move differently to what we expect. So now they wanted a sun that moves along, the sun's path, they wanted it to be on the celestial equator like this. They wanted it to be on the celestial equator instead of the ecliptic, like it really is. So they came up with a fictitious sun called the mean sun. This is a MEANSUN. So the mean sun moves from west to east, just like the solar sun, uniformly along the celestial equator, making one revolution in a year. So that is what they developed. A fictitious sun called the mean. They called it the mean sun, and it moves along the celestial equator. So now the interval between successive upper transits of the mean sun is called the mean solar day. Just know, just like the sun, it was just the solar day, an apparent solar day for the what? For the sun, for our normal sun, it was an apparent solar day. So now the interval between successive upper transits of a mean sun is called a mean solar day. So mean solar day is just interval between successive interval between successive upper transits, not successive upper transits of our mean sun, That is the definition of a mean solar day. So now, just like our normal day, our normal sun in our normal day, just like our normal apparent day, our one apparent day, the one mean day is approximately equal to one sidereal day plus 4 minutes sidereal time. That is just for the mean day. So how is this possible? This is what happens. Imagine we have our normal sun. Our normal sun travels in an ecliptic like this. Oh yes, our stationary is growing a bit. We have a red pen now. So yeah, our stationary is growing. So now here you see that is where our ecliptic, the red one, crosses the celestial equator, the black one. So here is going to be our V. The problem with our normal sun is the sun uses the ecliptic, so it travels along this red pen like this. That is the problem with our sun, right? It travels along the ecliptic like this. So what the astronomers did was they made a fake sun called the mean sun that travels along the equator. It travels along the equator like this. That fake sun. The relationship between them, the normal sun and the mean sun, is just here the mean sun and the solar sun, they are at the same point. So at this point here, the point V, the mean sun and the solar sun, they coincide. So they will be at the same point. As the original sun is moving on the ecliptic, this mean sun will move also in unison on the what? On the equator. So when the mean sun is at this point here, as the mean sun is at this point, the ecliptic, or the mean, as the solar sun, our apparent solar sun, like our normal solar sun, when it's here on the ecliptic, the mean sun will be here on the equator. So they move in unison as if they are connected to each other like this. They move in unison. And when the sun that moves on the equator, the solar sun, when it moves back to V, this one would have traveled right round. The mean sun would have traveled right round the celestial equator and back to V as well. So they move in unison. So basically they observe the same rule, that 1 mean day is approximately equal to 1 sidereal day plus 4 minutes sidereal time, just like the apparent solar. So let's see what help this has. This has great help because the mean day, now this mean day, you remember the solar day was defined to start, the apparent solar day starts at 12 noon. It starts when the sun is in upper transit. At 12 noon, that's when the solar day starts. But we know that our normal day on our watches, on our phone, or whatever, our normal day that we use starts at 12 midnight. It's because it's based on this mean day. So mean day, the mean day begins at midnight. Let me just say at midnight, and then I'll say what this point is. Our apparent solar day, the one that we discussed before, began at noon when the sun was in upper transit. But this mean day begins at midnight when mean sun is in lower transit. Now we are discussing lower transit. When the sun is in lower transit, that's when we start our mean day. The apparent solar day, yes, it starts when the sun that we can see is at upper transit at noon. But this mean day for this fictitious sun, it starts at midnight when that fictitious mean sun is in lower transit. So this basically means that it starts at 12 midnight, which is 0000. That's when the day starts. Even the day that you know right now, it starts at what? At 12 midnight. It's because it's based on this fictitious sun called the mean day, called the mean sun. So now, on March 22, I said what is special. What is special is that when the normal sun that you can see, the solar sun, is at V, the mean sun is also taken to be at V. So on March 22, the day when the solar sun is at V, our mean sun is also at V. So that point is very useful for us to start our normal day. So on March 22, the real sun will be at V, isn't it? On March 22, the real sun will be at V. So we are choosing our mean sun to coincide with the real sun at this time. So on March 22 at noon, on March 22 at noon, isn't it? At noon, where we are saying what? Our mean sun is at V. But what is special? Okay, let me write that down. Let me write that point down so that we break it down and see where we are going with, is at V. Okay, so let's look at what happens at V. If our original sun is at V, on March 22, well, where is V? V will be in upper transit. That's what we discussed when we talked about sidereal time. V will be in upper transit on March 22 at noon. So let's write the points for March 22 at noon. We know that V is in upper transit. So what this point, what does it tell us? This point tells us therefore that on our sidereal clock it's 0 hours sidereal time, because V is in upper transit. On March 22 we know that V is in upper transit, but V's upper transit means the sidereal time, the sidereal clock is starting, and we have 0 hours on our sidereal time. But looking at normal days that we know, at noon, what is the time at noon? It's 12 p.m., right? How many so now we see our midday starts at midnight. So at noon, how many hours is that after midnight then? So according to the mean day, according to mean time, now we are measuring mean time. Mean time doesn't start at noon. Mean time started the midnight before. That's what mean time. That's what mean time is. So mean time had long started the midnight before this March 22. So it started at 000. So at this special time, at this noon, it means on our mean clock or our mean time, we have 12 hours already. We have 12 hours mean time. So we can equate this now, because they are measuring the same point, isn't it? They are measuring the same point. The V is measuring the upper transit. So 0 hours on the sidereal time. So 0 hours sidereal time is equal to 12 hours mean time. This is what we were getting at when we were discussing what happens on March 22. So our 0 hours sidereal time is equal to 12 hours mean time on March 22 at noon. On March 22 at noon, I hope this makes sense. On March 22 at noon, V will be in upper transit. So our sidereal clock will read 0 hours. But on March 22 at noon, when you look at mean time, we'll be like, oh, but our mean day started at midnight. So how many hours is this noon, this time called noon? It's 12 hours after the day started. So on the mean clock, there are 12 hours that are there. So these two, we can equate them. 0 hours sidereal time is equal to 12 hours mean time. In the next video, we are now going to get into examples of how to relate sidereal time and mean time. So stay tuned for that one.